Hello everybody! Today I'm going to demonstrate a project we did for our multi-agent learning class. I did this with my awesome teammate Ritchie, and our GitHub repo is in the description down below, in which you can also find his GitHub repos as well. So we adopted the classic Pacman simulator from CISC889 from UC Berkeley and scaled it into multi-Pacman versus goats to do homogeneous reinforcement learning to get maximum rewards possible by eating the food dots, the power pellets, then goats, or winning the game, just like you normally do in a classic Pacman game. The implementation details and our experiment results are already illustrated in our report, which you can also find in our repo, so please check on that if you find it interesting. In this video, we will only demonstrate how the training works and how the evaluation process is going on. Okay, so let's just refer to the argument we used in our report. Well, of course, first you will have to download our repo. I will do this from scratch. This is the GitHub repo link. Let me copy it and git clone it. Then let's run by this argument. Here, the -p means that what Pacman types we want to use for training. In this project, we have written a SASA agent, which uses SASA algorithm, and a DQ agent, which uses a deep Q network to approximate Q value. So let's use them. By the way, our project is scale-friendly, so if you want to implement your own type of agent, which means you want to try your own reinforcement learning algorithm, just check out our agent class and try to replicate the attributes and methods. More details can be found inside of our report or go to CISC889 official website. Alright, let's get back to this. -x means how many training iterations we want to give for the game, in this case 20, so our agents will be trained for 20 rounds. And then -m means the number of total games, in this case 32. So 32 minus 20 equals 12 rounds will be used for evaluation purpose. You will see what that means once we get there. -l means what layout we want to use, and the Pacman amounts specify how many Pacman agents we want to put in the game. And these amounts correspond to the Pacman types we specified in -p. In this case, we will have one SASA agent, two DQ agents, another two SASAs, and another one DQ agent. Actually, just totally 3 SASA and 3 DQ agents. But why specify agent types repeatedly is because I want them to be drawn in different colors, so they are easy to be identified when graphics are shown. We have hard-coded different colors to draw a different type of Pacman based on their input order. So, like this first type SASA agent will be drawn in yellow. The second type 2 DQ agents will be drawn in red. Then these 2 SASA agents will be drawn in blue. Actually, I can't remember the exact color. And then this will be drawn, say, in pink. Training graphics will enable graphics for training the Pacman. And since training with the graphics can be very slow, so we add this training graphics update frequency to show the training graphics in certain interval. Like we have 20 training rounds here, and update frequency is set to 4, so game round 5, 10, 15, and 20 plus the first round will be displayed. During those training rounds without graphics, the console will just give related console output, and that speeds up the training process largely compared to training with graphics. The first round will always be displayed if you enable training graphics, and this eval graphics will show graphics for evaluation for every round. Okay, let's run that. You can see from the console output, our Pacman agents with their corresponding colors are shown here. Then you can identify them from the graphics. This is training round 1, so it says T1 here. Let's speed up the graphics till the end of training, and let's see what evaluation looks like. So after training, our agents have learned the parameters and stored them in the memory. Previously, we had also implemented a mechanism for the dequeuing agent to store its params locally to the machine. Please check that previous commits if you need them. And see how they perform here. Let's watch the first one and skip to the end of the evaluation since it will take a long time. Alright, now we've reached the end of all the evaluation process, and you can see our agents perform quite good actually. 100% win rate. So that's all about our multi-agent reinforcement learning Pacman project. We have learned a lot about multi-agent learning along the way. If you find the project interesting, again, fork it and try to implement your own RL algorithm and see how it goes. In the future, we may make the agents be able to communicate with each other, since they are not aware of the existence of each other right now. And when they can communicate, I guess the cooperation could make the game more fun. Also, if you have questions or want to discuss, please open an issue ticket in the repo. Thanks for watching.